So today we're going to talk about a little more about the percent change, which, as you already know, is about how much a quantity or something, a quantity, we'll say a quantity, changes compared to the original amount. Now, a quantity can either go up or down. You could get money, increasing money, or you could lose money, going down. Now, it's important that we remember which one we're talking about in each case. Some of these problems we're going to do are going to be about something, the number of students, the amount of money, anything going up, and that's going to be a percent increase because it's going up. But some of these problems are going to talk about something going down, the amount of money we have going down, the cost of something going down, the amount of people going down, and we're always going to want to call that a percent decrease, just so it's clear which one we're talking about. So, to take a first example, it's always good to think about money for our first examples. Let's say Mrs. Janice is walking home, and she has in her wallet $5 to start with. Yay for Mrs. Janice. But then she finds on the sidewalk another dollar and 1, 2, 3 quarters. So altogether now she has this much money. Now if we look at that money, we see it's 5 plus 1, 6, 25, 50, 75. So now she has a total of $6.75. Good for her. But how much did it go up? What was the percent increase, or how much did her money go up? How much did it change? To do that, we can use the percent increase. How we're always going to find this, we're always going to find the percent, and I'll use that sign, increase, by first figuring out the amount changed. The amount that changed divided by, or over, you can say over, you can say divided by, the original amount. Which is how much we started with. So let's think about this problem and then fill in the blanks. For our percent increase, we got to figure out the amount changed first. How much did she find on the ground? Well, she found $1.75. So I'll write that in the decimal form. And then how much did she start with? What was the original amount? Well, that was $5. This is what I want to do. I can do this either on paper with long division, or I can plug it into my calculator. For these types of problems, I'm totally fine if we use a calculator. We've already worked on how to do this long division with decimals. So for now, go ahead and plug this into your calculator. $1.75 divided by $5. And what do we get there? Go ahead and do that now. You should get, when you do that, 0 and 35 hundredths. Now, this is our answer in a decimal form, but I want a percent increase, So, to take a decimal to a percent, what do I have to multiply by? I need to take that and multiply by 100, which you can do in your head or you can do in your calculator, which would give me a final answer of the 35% increase. That would be my answer right there. Now let's look at another example, a different example, not only of percent increase, we can also do this for percent decrease, how much something changes going down. But lucky for us, it's the exact same math. We're always going to come right back to this equation here, figuring out how much it changed. I don't care if it went up or down. How much it changed divided by what we started with. So let's do that in another problem. Let's say we have a pair of shoes on sale at a store. So the price of a pair of shoes increases from $52 to $64. What is the percent increase? So for this, we need to plug the numbers we know into our equation again. We're finding the amount changed. Divided by the original amount. So what does that equal? Well, for the amount changed, we're going to take what we started with, or the biggest number, minus the smallest number. So whichever way, if you're confused about which number should go first, always start with the bigger number. Always start with the bigger number here. In our case, it's 64. So I'll plug in 64 minus the other number, 52. That's going to tell me how much it changed. And then all of that's going to go over the original amount, which in our case, it started at 52. Now you can do that in your head, plug it into your calculator, either way. On top, I'm going to get 12. That's the amount it changed. On the bottom, I still have 52. Now again, you can plug this into your calculator or do it on paper, the long division, and you should get about 0.231. Now that's rounding a little bit. This is a long decimal, but we can round to about 3 or 2 decimal places. Now I have this answer. This is my answer in a decimal form, but I want the percent increase. So again, I have to always multiply my decimal answer by 100, which you can do in a calculator or in your head, just moving the decimal place over 2 spots, and I would get about 23% as my final answer. So the pair of shoes increased, had a percent increase of 23% in cost. Not too bad, not too bad. Let's try one more problem like this. Another thing with money. So a bike is selling for $112. After a week, it goes on sale for $95. So now it's less money. It was $112, but now it's $95. What is the percent decrease in price? So now the amount of money is going down, which is why it's a percent decrease, but the math is going to be exactly the same, Let's look at that. We need the amount changed over the original amount All right, so the amount changed. Again, I'll start with my biggest number, which in our case is 112, minus the other number, which is 95. I'll put that all over the original amount, or what we started with. In our case, the bike started at 112. Now this, I can do on paper, in my head, or plug into a calculator, either way. When I crank that out, I get 17 over 112. This again, calculating that, I'll get about 0 and 1517. Can round there. And then finally, I will multiply by 100, as we did for our last problem. Move the decimal place over twice, and I'm going to round to just a whole number, which is okay for these percent problems, ending up with about 15%. So, our bike, the percent decrease in price was 15% for our bike. Now, these both were money problems, and money is always a great thing to think about, but this can work with anything. People, the amount of donuts, cats, dogs, I don't care, anything. So we're going to do one problem where it's with people, the amount of students in a class. At the beginning of a school year, a math class has 30 students. By the end of the year, there are 33 students. So what is the percent increase? Now, we know this is a percent increase problem because it tells us, but we also know because the amount of students went up. It went from 30 students to 33 students. So let's try that problem now. I'm going to do the exact same thing. The amount changed. Over original amount. So I have 33 minus 30 over what we started with. We started with 30 students. You can do this in your head or on your calculator. I get 3 on top I still have 30 on the bottom. Again, in your head, on paper, on a calculator. And I get 0.1. I multiply that by 100. And I move the decimal place over 2 spaces. Careful here, make sure you move it over 2 spaces. Don't be multiplying by 10, multiply by 100, and you should get 10% as our final answer. All right, go ahead and rate yourself on this next question on how you feel about doing this type of problem. You're going to be using this on your project. We'll talk more tomorrow about how this works for prices, like when things go on sale or when things get marked up for store prices. But I want you to go ahead, use what we learned today, keep working on your Shop Till You Dropped math project.